Okay, good morning. Today, for pre-calculus, I'm going to be covering more on trig functions, including sum and difference formulas. Okay, so there is a few formulas over here that we're going to look at first. These right here. Okay, I got one for sine, actually two for sine. There's a plus or a minus there, the red, or the blue or the black. So if I was, let me zoom in for a second. If I was doing the top one, right, if I said it was x plus y, then I would use the plus over here, okay? If it was a minus between the x and the y over here, then I would use the blue minus, okay? So it's going to match whatever sign I see between the x and y over here. So if that's a plus, then it's a plus on the right. If it's a minus, then it's a minus over on the right between the over here. Okay, so this will match. Now, if I go to the cosine, it's the opposite. They're not going to match. So if it's a plus between the x and the y there, then it's going to be a minus over here, okay? And if it's a minus between the x and the y over here, it's going to be a plus. So those are not going to match. They're going to be opposites, okay? So that's how those formulas will work. And rather than writing down each formula twice, we did it that way. Now with tangent, I wrote down separately. I don't know why, but I guess it's not quite as easy. So these are the tangent formulas. I'm going to do one of these towards the end of the video. More often we're using the sine and the cosine for these problems. Okay, so those are the formulas we're working with in this section. Now, for this particular first problem, solve between 0 and 2 pi. So what happens with this is because I have the tangent of 2x, instead of going between 0 and 2 pi, I'm going to double that, okay, because of that 2 in front of the x. So I'm going to go between 0 and 4 pi, okay? So I want to find out all the answers that are there. Because of that 2, it changes the parameters for the answer. All right. So yeah. All right. So first thing I'm going to do is I'm going to find the reference angle. All right. Which angle, when I take the tangent of it, gives me 1? Well, that's a 45, 45, 90, which means my reference angle is 45 degrees. We're working in pi's or radians, which means it's pi over 4 is the same as 45 degrees. Now, the tangent is positive in the first and third quadrants, which means that's where my reference angles go, which means that those two answers will be pi over 4. And if I went over into this quadrant here, that would give me 5 pi over 4, okay? Remember, halfway around the circle is pi, so that's 4 pi over 4 plus 1 more pi over 4 gives me 5 pi over 4. So those are my two answers between 0 and 2 pi. And then if I add 2 pi to those, because I want to go around the circle one more time, because I said 0 to 4 pi, I add 2 pi is 8 pi over 4. So if I add 8 pi over 4 to both of these, I'll get my other two answers, which are 9 pi over 4 and 13 pi over 4, okay? And those are all the four answers that I'm going to use. The last thing I'm going to do is, because I have that's what 2x equals. I divide all those four answers by 2, okay? And now I'll get all four of my answers that are now going to be between 0 and 2 pi, okay? So that's why I did that, because there was really more of them than originally thought, because it's got that 2x next to the tangent, okay? So pi over 4 divided by 2 is pi over 8. 5 pi over 4 divided by 2 is 5 pi over 8. 9 pi over 4 divided by 2 is 9 pi over 8. So you can see I just doubled the denominator, and that's the same as dividing by 2, all right? And those are my four answers, okay? And that's your first problem. Next one. Sine of 2x equals 3 pi over 2. So same thing. Usually I'd go to 0 to 2 pi. This time I'm going to double it because I have that 2x in there, okay? So now I ignore the 2x for a while and I solve it like a regular problem. and I say which angle gives me the square root of 3 over 2, and hopefully you've realized by now that's going to give me a 30, 60, 90 triangle. So if I'm looking at the 30, 60, 90 triangle, sine is opposite over hypotenuse. Which one's opposite? The square root of 3, well, that's the 60 degrees. So 60 degrees is my reference angle, which is the same as pi over 3. So the sine is positive in the first two quadrants. So if I take those two and I figure out what these angles are, the first one obviously is pi over 3. And then if I go all the way around over to here, so that halfway around would be 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. Those are my first two answers you can see here. So once again, I got those two answers. Now I want to have it go all the way to 4 pi. So if I add 6 pi over 3 to each of those, then I'll get once around one more time. So if I remember 2 pi is once around the circle, so I want to add those two. So if I add 6 pi over 3 to those, I get 7 pi over 3 and 8 pi over 3, because 6 pi over 3 is the same as 2 pi. All right. And the last thing I do is I divide everything by 2. So once again, when you divide by 2, you can just double the denominator and get your answers: pi over 6, 2 pi. Pepper. Divide by 2, multiply the denominators by 2, and get all your answers. Okay? You got a little thrown off there by Pepper making an appearance. My cat, Pepper. All right. So those are my 4 answers. Next one, secant of 3x. So last time we had 2's in front of the variable there. This time it's a 3. So I multiply 0 and 2 pi by 3, and I get 0 and 6 pi. So this time we're going all the way up to 6 pi, and we'll see how that works out. So the secant, the inverse of the secant is the cosine, right? So I could flip the 1 upside down to turn this into a cosine problem, because cosine is much easier to work with than secant. So if I flip 1 over 1 upside down, I get same thing, 1 over 1. All right. So I'm looking for the cosine of what gives me 1. So that's one of the corner angle things. You know, it's going to be the coordinates of the circle. Hopefully you remember that the cosine is the x coordinate. All right. So these are my 4 corners of the unit circle, and the cosine is the x coordinate. So I'm looking at, there's a -1, there's the +1. So +1 is the only one is 0. All right. So I'm looking at 0 or 2 pi, and remember I'm going all the way up to 6 pi, which means 0, 2 pi, 4 pi, or 6 pi. Okay. So I got all of those, and if I divide all of those by 3, I get 0, 2 pi over 3, 4 pi over 3. And 6 pi over 3. Now, if I divide 6 pi by 6 pi over 3 out, I get 2 pi, all right? And the answer is actually supposed to be between 0 and 2 pi. So see how it's not included over here because of the parentheses. So I'm going to throw that one out, and I got 3 answers. Okay? So that one actually turned out to be a little shorter than some of the other ones because it was on the unit circle instead of being a 30, 60, 90 triangle, for example. Less answers, which was nice. Number 4, tangent squared. All right, so I'm going to do one of these squared ones. These end up having more answers. So first thing I'm going to do, if I took the square root of both sides, I get tangent of 2x equals plus or minus 1. Next, so tangent being 1, that's a 45, 45, 90 triangle, and you will see quickly that tangent is going to be, the reference angle will be 45 degrees, and since it's plus or minus, I'm going to get all 4 quadrants going. All right, so I'm going to have reference angles all over the place here. I'm going to have this one, that one, that one, and all of these are going to be pi over 4. So if I do all 4 of those out, I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And now, so once again, because this one had the 2x on it, instead of going to 2 pi, I'm going to go all the way to 4 pi. So if I just add 8 pi over 4 to all of those, I'll get my other 4 answers, like these over here, 1 pi over 4 plus 8 pi over 4 is 9 pi over 4. 3 pi over 4 plus 8 pi over 4 is 11 pi over 4, etc., etc. I get all of those answers. So all of those are what 2x equals. So the last thing I do now is I divide all of those by 2, double the denominator, leave the numerator alone, and I get pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, and 13 pi over 8. And those are all of my answers for this particular problem. So you can see when you have that squared there, you get a lot of answers. Okay. Oh, whew. Almost tired from saying all those pi's. All right. Number 5. A little different. If I have tangent of x over 4 plus 1 equals 0, so no squared on this one, which is good. So the other ones I had 2x, for example, in there, and I went from 0 to 4 pi, so I doubled it, right? Because it was a 2. This one, instead of having going from 0 to 2 pi, and I have pi over 4, I'm going to go between 0 and pi over 2, okay? So the other thing I did was I subtracted 1 from both sides here, and I'm looking for the tangent of what angle gives me negative 1. So tangent being 1, forget the negative for a moment, that gives me a 45-degree reference angle, okay? Because my triangle over here, right, 1 over 1, opposite over adjacent is tangent, which gives me 45 degrees. So my tangent is negative in the second and the fourth quadrant, which means my reference angles are going to be 3 pi over 4 and 7 pi over 4. So those are the two things that x over 4 equals, okay? So now instead of like dividing, I'm going to multiply both of those by 4, and I get 3 pi and 7 pi. Now, here's the funny thing about this one, because up here, remember I said it's got to go between 0 and pi over 2. Neither of those answers are between 0 and pi over 2. Therefore, I'm going to put this clause in here, and I'm going to say there are no answers between 0 and 2 pi, okay? So that's the way you phrase your answer there. All right, next problem. So this is the next one, a little different. I got two things that multiplied together equal 0, all right? So there's that wonderful thing, just like when you factored, take what's in the parentheses, set them equal to 0, and then solve. So I'm going to have two different sets of answers here, one for the sine of 2x equals 0, and the other one for the cosine of x over 2 plus square root of 3 over 2 equals 0, okay? So I set them both to 0, and then I solve them, all right? So sine of 2x equals 0, let's start with that over here. If I take that one, something being 0, that's corner angles. The sine, remember, is the y coordinate. So if I look at these, there's two of them, right? Either at 0 or at 180 degrees. 180 degrees is pi units. So I got 0 or pi. And once again, since this is a 2x up in here, I'm not going to go between 0 and 2 pi. I'm going to go between 2 pi times 2 is 4 pi. All right, so I'm going between 0 and 4 pi. So 0, pi, 2 pi, and 3 pi, okay, are my four answers. And then I have that equaling 2x, which means I divide all of those by 2, and I get 0, pi over 2, pi, and 3 pi over 2. And those are my four answers for that one. But I'm not done. I got to go back and do the cosine one. So I have cosine of x over 2 plus square root of 3 over 2. So the first thing I'm going to do is move that square root of 3 over 2 to the other side by subtracting it. And I get cosine of x over 2 equals negative square root of 3 over 2. So negative square root of 3 over 2, that's definitely a 30, 60, 90 triangle. And if I look at the 30, 60, 90 triangle over here, I find out Remember that the cosine is the adjacent over hypotenuse. So which is adjacent to the square root of 3? That is my 30-degree angle, which means 30 degrees, or pi over 6, which is 30. Okay, so pi over 6 is my reference angle, and it's negative, and the cosine is negative in these two quadrants, number 2 and 3. So if I make my reference angles in there, so this would be 5 pi over 6 and 7 pi over 6. And I double it. And we threw out the 7 pi over 6 because when I double it, it's bigger than 2 pi, so I tossed it out. Small potatoes, but anyway. So 10 pi over 6 is my answer. I guess you could reduce that to 5 pi over 3, but I'm just going to leave it like that. Okay, next one. So now we're getting into the sum and difference formulas, okay? So please, here's a big don't do. If you have the sine of 30 plus the sine of 60, don't go sine of 30 plus the sine of 60. That's not right. So here's the first problem. Number 7, sine of 75 degrees. 75, I can break, all of these can be broken up into 30s and 45s or 60s. Okay, those three are the big numbers. Maybe a 90 sometimes, you know, or 180 if you can use those. Those are nice because they're corner angles. So this one, 30 plus 45. So I'm going to use that formula since there's an addition sign between them. I'm using this one just like it's written at the top of the page. We started at the beginning of the video. So I can break this up. So 30 degrees is going to be my x, and the y is going to be the 45. And if I plug those numbers into my formula, I'll get this. Everywhere there's an x, I put the 30. Everywhere there's a y, I put the 45. So you get the sine of 30 cosine of 45 plus the cosine of 30 sine of 45. And now I'm going to my triangles, okay? This is all 30, 60, 90, 45, 45, 90 triangles like I got over here on the right. And with those, sine of 30, sine is opposite over a hypotenuse, which gives me 1/2. Cosine of 45 is 1 over the square root of 2. Cosine of 30 is the square root of 3 over 2. And the sine of 45 is 1 over the square root of 2. Now, just a quick reminder, 1 over the square root of 2 is the same as square root of 2 over 2. You know, if I rationalize that denominator by multiplying top and bottom by the square root of 2, you get square root of 2 over 2. This is going to be easier to work with in this particular part, so we're going to go with square root of 2 over 2 from here on out instead of 1 over the square root of 2, okay? You'll see why in a minute, because when I multiply these together, when I multiply 1/2 and square root of 2 over 2, I get square root of 2 over 4, okay? 2's in the denominator by accident. It should be 4's, okay? Because you multiply fractions, multiply the tops together and the bottoms together. 2 times 2 is 4 for my denominator. Square root of 3 times the square root of 2 is the square root of 6, okay? So you can either leave it like that as square root of 2 over 4 plus the square root of 6 over 4, or you can combine, add the numerators together and keep it over the same denominator. That is fine too, okay? Any of those are just great. And that's your answer, okay? All that work for that. Next one, cosine of 75 equals the cosine of 30 plus 45. So you want to break up 75. Sometimes they'll give it to you that way, and sometimes they'll make you figure out how to break up 75. So this one's nice. They're all acute angles, so I'm all in the first quadrant. Don't have to worry about any negatives yet. So if I break this one up, it's got a plus sign here. So I am using the plus cosine formula. So it's a minus between the cosine and the sine. And now I'll plug in the x's and the y's, the 30 and the 45 in other words. So I get cosine of 30, cosine of 45, minus the sine of 30, sine of 45. Now I'm going back to my two triangles, the 30, 60, 90, and the 45, 45, 90, and figure out each one of these four things. So the cosine of 30 is the square root of 3 over 2, right? Adjacent over hypotenuse, adjacent, hypotenuse, square root of 3 over 2, first quadrant. Cosine of 45 is 1 over the square root of 2, which we already said is the same as the square root of 2 over 2, so I'm using that one. Sine of 30 is 1/2. Sine of 45 is 1 over the square root of 2, which we're using that square root of 2 over 2 again. As I said before, we rationalize the denominator. This will make it easier. So now I multiply these together, multiply the tops together and the bottoms together. I get the square root of 6 over 4. And the other one, if I multiply 1 times the square root of 2, I get the square root of 2. Denominator will be 2 times 2 is 4. So you can either write it as 2 fractions or as 1 fraction. Those are the same things. Either one is just fine. Okay? That's the answer. That's it. Number 9. So 300 minus 45. So this one, we have something that's not in the first quadrant. So we're just going to have to keep an eye on the positives and negatives. That's really the big difference between this one and some of the other ones. So I'm using the same thing, the sine formula with the subtractions, which means I've got sine x cosine y minus cosine x sine y, all right? And now I plug in the 300 and the 45 for x and y, and I get this here. All right, all I do is plug in the numbers. So you need reference angles for this. So sine of 300 degrees is like all the way around to here, which means I got a 60-degree reference angle, okay? So I'm looking at the 60 degrees being the reference angle for all of those where it says 300. The thing that's different is, remember, the sine is positive in the fourth quadrant, but the cosine, sorry, I got that backwards. The cosine will be positive, and the sine will be negative in the fourth quadrant. So when I look back at my 30, 60, 90, and 45, 45, 90 triangles, and I'm doing out, that's the sine of 60, except it's going to be negative. So sine of 60 is over here. That's opposite over hypotenuse, make it negative. Cosine of 45 degrees is the square root of 2 over 2 from my triangle over here. 1 over the square root of 2, rationalize the denominator. Cosine of 300 is 1/2, because that's the same as the cosine of 60 with my reference angle. Sine of 45 is the square root of 2 over 2, and then I multiply the fractions together. Okay, square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4 for the denominator. 1/2 times the square root of 2 over 2 is square root of 2 over 4. And you can write it as 1 fraction or as 2 fractions. And that's your answer. Okay? That's number 9. Number 10. This one. So, I was checking to see if I could combine these two together, you know, because that's like a cosine, cosine, sine, sine. Sometimes you can save time by figuring out that way. This one didn't happen to work because if I subtract those, I get 265, which doesn't really work. So, but there's another problem coming up in a little bit that I will be able to do that. 265, the reference angle ends up being not something I can work with without a calculator. All right, so cosine of x. So once again, if I have a 300-degree angle, that leaves me with a 60-degree reference angle. Okay, so I'm looking at 60 degrees, and the cosine is positive in that quadrant, and the sine is negative in the fourth quadrant. Okay, 45 is in the first quadrant, which means it'll all be positive. So I'm just going to break these down. Instead of having to use the formula, I just go straight to what is the cosine of 60, which is 1/2. So that's where I got here. Cosine of 45 is square root of 2 over 2. Sine of 300 is the same as the sine of 60, except it's going to be negative. So that's the square root of 3 over 2. Sine of 45 is square root of 2 over 2. And then I multiply my fractions together. And I get the square root of 2 over 4 minus the square root of 6 over 4. And you can either write that down as 1 or 2 fractions. Okay? And that's it. Yeah. Next one. Cosine of pi over 4 plus the cosine of pi over 3. This one's pretty straightforward. You know, we've been doing these all day. If you know that the cosine, the pi over 4, that's 45 degrees. You know, what's the cosine of 45? Pi over 3. That's 60 degrees. What's the cosine of 30? You know, so if you look back at your triangles, you get that cosine of 45 is square root of 2 over 2. Cosine of 60 is the square root of 3 over 2. And then I can either leave it like that, or if you want to add them, put them over the same fraction, write them as one fraction or two, you can. All right. That's it for that one. That one's kind of straight up. All right, next. So this is one where I'm looking at the formula because this is an addition kind of problem. Cosine, cosine, sine, sine. That's the cosine sum formula, which means x would be 25 and y would be 20, which means if x is 25 and y is 20, I can add those two together in here, and I get this, the cosine of 25 plus 20, which is the cosine of 45. And 45 cosine is square root of 2 over 2, or 1 over the square root of 2, right? And that's my answer. So that's pretty quick that way, all right? So that was real nice and easy. I like it when they give it to me like that. All right, next one. I got all variables in this one, okay? So I'm not going to be able to come up with such a nice, neat answer as I did above, where it's like square root of 2 over 2. But what I do need to do is I need to figure out which formula to use. And since I see there's a sine cosine minus cosine sine, I can see that that's going to be a sine of x minus y, okay? Now, x is going to be 2x, y is going to be 3y when I plug that in. And I get this, okay, sine of 2x minus 3y. And that's just as good as that gets, okay? There's nothing more I can do with that. So I'm moving on to the next problem after that, all right? Next one, number 14. Cosine of pi over 12 times the cosine of 5 pi over 12 minus sine of pi over 12 times the sine of 5 pi over 12. So I can see that that's a cosine problem because it's got cosine, cosine, and sine, sine together, which means it's going to be cosine of x plus y. And so x is going to be pi over 12, y is going to be 5 pi over 12. And if I add those two together, I get cosine of 6 pi over 12. And 6 pi over 12 is pi over 2, which means I'm looking at a corner angle, and the cosine is the x-coordinate, which is 0. And that's the answer. All right, that was nice. I like that one. Okay, next one, tangent. I'm doing one tangent problem with you guys here. Tangent of 300 minus 45 equals tangent of 255, okay? So it's a tangent, it's a subtraction problem. That's the formula for the tangent and subtraction. Once again, so my reference angle with 300 is 60 degrees, okay, because almost made it all the way around, which means the tangent is positive in the first and third quadrants and negative in the second and fourth, which means it'll be negative in that quadrant, okay? So if I plug in the 300 and the 45, I get this. I get the tangent of 300 minus the tangent of 45 over 1 plus tangent of 300, tangent of 45. And then if I take the tangent of 300, or the tangent of 60, I get the square root of 3 over 1. And it's negative, so I got negative square root of 3. Tangent of 45 is 1, going from here to here. Here, there. And tangent of 300, once again, is negative square root of 3 and the 1, so I did out the denominator here, which means if I simplify that, I get the negative square root of 3 minus 1 over 1 minus the square root of 3. And I'm just going to leave it like that. I know it's not a rationalized denominator, but I'm not worrying about that at this moment. Okay? And that, my friends, is my last problem, so I'm going to stop. If you have any questions, please bring them to class. Thank you very much. Have a great evening.